visible? Perfect. All right. So, there are many ways to achieve Azure well-architected framework-based, best practices for resiliency or reliability perspective, and we'll just explore 5 top reasons, how you can get there, and what kind of help we can offer from a Appranix perspective is the conversation today. Right? Given that, I don't know if you had a chance to look at the well-architected framework. In general, this is in preview still. And if you look at it, there are 5 pillars. Pillars like operational excellence, where running and monitoring the system to deliver the business value is very important. Second aspect is that once you have that basic capability, and including ways to train your staff, and if you're moving from your data center, you train that the entire team, then you get ready for an efficient operation on Azure for your applications. Third is security. I mean, you have seen every day on the national newspaper, national news, that the systems are getting attacked with some kind of a ransomware, right? Even today, there was another article about the largest meat producer in the world, JBS, has paid $11 million for a ransomware attack, and they are trying to be back online. Similarly, every day for the last 2-3 months, there's some kind of an attack happening. So security is such a critical thing for you to take care. And fourth is the cost optimization pillar, where you kind of settle down, you optimize to a point, and then if you have democratized the usage of the cloud, and the DevOps folks and the developers in general, they are producing their own infrastructures using the code. So it is easy nowadays, at least for an enterprise, so large enterprises, to lose track of where the spending is going. That has been a big problem. So you will have to really think about how to optimize that cost. But the aspect that we'll talk today is about reliability. Reliability to achieve the application resilience, the applications that are running on the Azure infrastructure, how to achieve much better resiliency than what you might have achieved already, or trying to get there even before migrating your applications over to the cloud. So for that, what I'm going to give you is the Azure website itself. So if you go to the Azure well-architected frame view, so if you type for my Azure assessments, it's still in preview mode. So if you look at the assessment location, you can simply just type on Google and you'll get there. There are various assessments. So if you think about an assessment, it will be delivered as a report after you go through your own assessment, self-service assessment. You can see various components or various pillars of the Azure well-architected framework. And in every one of them, you have a ton of these questions, and there are like 22 questions for, in general, total for just cost optimization and reliability and performance efficiency. If you think about it, there are about 64 different questions. Within those questions, you have sub-questions, sub-categories that you have to worry about. Obviously, this is a large exercise that we are not going to go through in this particular webinar within an hour. If you have some time with respect to reliability, we can certainly help you in terms of how you can achieve that. But within the reliability component or the pillar itself, if you look at the subcategories of the reliability component, is that how do you really define that reliability? What is that SLI? So if you choose that reliability, if you go into subcomponents of that, obviously you have multiple questions where Microsoft is trying to assess what you have, what you already deployed, and what you plan to deploy in terms of applications and so on, and what's your idea about recovery time objectives and recovery point objective and so on. depending on your service levels that you have promised to your business divisions, and also think about how you can achieve them. So there are several components in terms of RTOs, RPOs, SLAs, and the mean time between failures and recoveries, and so on. And if you go to the next level, you have application level components that you have to take care. When you deploy your applications on Azure, obviously you have the choice of taking advantage of all kinds of region level resiliency available at the infrastructure level and zonal level resiliency available within the same region itself, and the service level availability with respect to load balances, with respect to other components of the Azure infrastructure. And once you get beyond that, you will have to also look at the capacity implications of that, right? So, for example, you might have deployed on the East Coast for your application. You might have taken advantage of all the capabilities available in the East Coast. That doesn't mean that when you try to fail over to another region of Azure, you will have all the resources available and also the capacity of those resources available in the other region. In its typical situation where in the largest of the regions, you might see multiple zones, 3 to 4 zones, and some of the regions might have just 2, right? Some of the recently deployed ones just might have one huge data center, right? May not have additional zones. So if that's the case, how do you really plan for those capacity limitations or capacity planning wise you'll have to take care? Now, once you have all of that, are you ready for handling the disaster recovery? So, in the case where the applications fail, especially when you operate your applications on a public cloud, it's a shared infrastructure, which means that applications could come down at any point in time for various reasons. We'll outline what those common reasons are. We will do a quick polling as well. And once you have that assessment, now how do you really fail over to a different region, or even within the same region, how do you really fail over to another zone if you haven't really coded or taken advantage of 2 different zones or 3 different zones within the same region? Now, once you go through that, from a reliability perspective, you got to have an idea what that really means, right? Everyone has reliability definitions differently. If that's the case, what's your definition? How have you changed your applications, if you have changed your applications or re-platformed your applications after moving to Azure, right? So there are levels of infrastructure usage as well as application level capabilities that you'll have to leverage. Plus, in terms of installing the tool sets, the health probes, or if you are using some of the monitoring tools, how do you really take advantage of that? So likewise, you can see there are about 13 subcategories of these questions, and every one of those questions have sub-questions again. So if you go in here, you have a very, very specific area where you will have to self-assessment. So you can be very honest about what you have, what you don't have, or what's possible on Azure. Is it geo-redundant storage requirement or local region redundancy is sufficient? Do you need to really have a geo-replication capabilities for some of your virtual machine or container components that you're running, or databases that you might be running, depending on how you want to really do that? And are you really probing the load balancers appropriately? Or are you backing up those load balancers so that when you bring back those load balances in another region, are you able to handle that kind of a configuration changes on the other side? Or are you able to retain those? Similarly, there are many of these questions. Obviously, it would take time depending on the type of infrastructure that you have deployed. And it is definitely fruitful, definitely worthwhile to go through these assessments just on one of the pillars, right? Not all the pillars, but one of the pillars will give you that idea of what's really involved in terms of deploying your applications and running those applications properly. Then you can go to the other areas. So with respect to the reliability, our overall resiliency perspective, it's very clear that there are several components, but we'll take one view of that, right? And we'll go into the details of how you can actually achieve that application resilience. Are there tools available in the market to give you that confidence, give you that peace of mind that you could achieve a level of application resiliency that wasn't possible before? In fact, the level of resiliency that you can achieve on Azure is much better compared to what you would have achieved in your own data centers, even if you have customized all those components that have been assembled from various different vendors and management tools and layers of complexity. That's one of the reasons why you want to drop probably all the technical debt and move to Azure. Now, when you think about your applications, when you think about various components of those applications, right? The applications are becoming a lot more dynamic, and the scale at which now you're dealing with those application components are much different from the data centers. As an example, this particular application, this is a financial services application that is doing about $16 billion in mortgage payments every quarter, right? Every quarter, which means that is mission critical for this particular customer. And that customer is operating tons of infrastructure on the public cloud. Now, when you think about your application components, dependencies and configurations and the state at which you operate, right? Do you have an idea how resilient your applications are? If that is the case, then you'll have to really think about, is your application highly available? When we say high availability, then you may have an idea about mean time between failures and how you can actually recover from those failures. What is the mean time between recoveries? And second important component is obviously the backup and DR. Now, are you really protecting your application components? And various components might involve different types of RPOs and RTOs, recovery perspective. An application might demand less than 15 minutes recovery. In some cases, the applications are okay, even if you could recover within like a day or so. But in the worst case scenarios like ransomware attack, obviously you want your applications to be back as soon as possible. That's when it hits. Do you have what it takes to be resilient on a public cloud with a shared infrastructure when so many of other customers are operating in the same region, right? In a shared infrastructure mode. That's when you have to think about what your application resiliency, and that falls on you. If that's the case, what are the common situations where the applications have failed? Again, we typically launch a poll to identify some of your scenarios where you have gotten in terms of the situation where applications might have failed. So why don't we, different reasons. And most of the reasons that we have seen is misconfiguration. And second reason that we don't get informed, but people really say it's a ransomware attack or some kind of a local service failure or configuration drift. And when that happens, obviously there is reputation damage, lost revenue, and you throw in a bunch of engineering resources and time to recover from those failures, right? And when you think about that situation, that's when you think about, okay, so are there ways, are there recommended ways, the well-architected ways that other Azure customers are following, or is there a prescription that's available from Microsoft to think about the resiliency? Yes, there are. So first thing is that you need to know what you're dealing with. In terms of knowing your application environment is very, very critical, right? That means that you should have some mechanism to continuously discover your application environments to know if your application environments are changing, the configurations are changing or not. Second thing is that make sure your data infrastructure is solid. When I say data infrastructure, it's not only the, putting together the storage infrastructure with the compute and making sure that storage infrastructure is available. I'm talking about data infrastructure. When it comes to data, data protection is key, obviously, and also the ability for you to recover the data with respect to a particular application is very, very important. Now, if you consider using some kind of a mechanism that you used to use before, let's say in the data center with some kind of a backup and recovery tools, the problem here is that the cloud-based infrastructures are different in the sense that if you try to pull the data over through the same production network to a third-party data management system, you not only delay, but also recovery gets delayed as well. So RPOs and RTOs could be lower than what you might have gone through when you were in the data center. So you'll have to really think about leveraging all the built-in Azure capabilities. Third is that, are you able to go back in time in terms of your resources? Do you have a mechanism to identify what those misconfigurations are? And even if you have identified those misconfigurations, have you had a mechanism to remedy those misconfigurations quickly? What that means is that you got to have some kind of a backup mechanism available for your configurations for all the resources, right? Fourth, how do you really recover from those problems? In the sense that, the dynamism and the scale at which the cloud infrastructure is getting operated as your developers deploy more and more infrastructure easily, the dependencies of those infrastructure is becoming very difficult to manage, meaning that even if you try to recover some of the resources that have been kind of misconfigured, and because of which the resiliency has been affected, your application has gone down. Now you have to really think about how to really recover from those scenarios, right? So that's when it's important to have a solid recovery mechanism that is aware of the dependencies all the time. And then make sure that you tested some of these recoveries time and again, right? Depending on the availability of the resources, depending on the availability of human resources as well, depending on the skill sets, it is better that you do frequent tests, because it is not your data center, it's not your own infrastructure, it's a shared infrastructure that you're operating, which means that, just like a pandemic, it has to hit just once in a lifetime, and the situation could be really, really worse. So how do you really plan on recovering from those failures? That's very, very key when it comes to the public cloud. Now, this is where we could help. Appranix, as of today, is the only solution available in the market to give you a coverage for well architecture, Azure well architecture for resiliency. We are not covering everything. There may be implications of coverage with respect to security automatically because we have the resiliency coverage. Appranix covers fully or partially about 67% of those requirements. You're talking about 103 different subcategories and subcategories, and within which we have gone through a full report in terms of how we can really achieve that Azure coverage. So if you think about it, this is our report. We have gone through this extensively with respect to each and every component of it, and we have marked whether it is partially successful or fully possible to achieve with the capabilities of Appranix. And the rest, you can actually achieve with Azure native management tools and also your own application level changes. How you really install your monitoring systems and so on is very important. Now, how do we help you in terms of achieving that level of resiliency? Just imagine you have a very complex or low complex. This environment runs about 53 to 55 different infrastructure components, load balancers, and instances, and so on. And the infrastructure as code, if you think about it, it takes about 14,000 lines of cloud native infrastructure as code that needs to be created to really create this type of environment. So a decent environment, which is obviously very, very business critical for that particular customer, financial services customer, which is doing about $16 billion in mortgage payments. So Appranix automatically discovers and reverse engineers the entire application environment, the dependencies of that, the configurations of these components, and also the state. Every time you change some kind of a configuration state, Appranix knows that based on the policies that you have configured. Now, after the configuration of the policies, what it does is that it creates something called Azure Cloud Time Machine, right? And the way we do it is that no agents, which means that even if you have configured your virtual machine scale sets to automatically scale horizontally, Appranix automatically captures not only the virtual machine scale set configurations, as well as all the components underneath, which is the configurations of the application workloads. The infrastructure associated with those application workloads are automatically captured as well. The environment metadata backup and recovery happens for the environment metadata. Network services backup and DR is possible completely with that discovery. Now, the second most important thing is how you really manage the data copy of your application infrastructure. And that has to happen really, really fast as well. The only way that can happen really fast to cut down your RPO so that you don't you minimize the data loss, right? And also the recovery time has to be improved. So how fast can you recover from those failures is such a key thing, especially when you're operating on the shared public cloud infrastructure. And we do it with 4-hour incremental agentless approach, so that works on auto-scaled environment as well. You can do it with multiple levels of resiliency, local, region, and backup and recovery type of resiliency, and cross-region replicated environment for cross-region recovery as well. Third, another most important thing is that everything happens with a low-code mechanism, right? It is all backended with the cloud native, Azure native infrastructure as code using ARM templates. You could have your Terraform templates used for your production environment. Continue to use it. Please do not change any of that. We do not affect the production environment. We simply sit behind and provide resiliency for your production environment that may be changing every second based on our multiple times in a minute, right? But depending on the number of developers that are changing your infrastructure, number of deployments that happen in your application environments, and the configurations that might be changed through third-party tools or through your own personnel or the managed service provider changing the configurations at the network level, the load balancer level, the workload deployments level, and maybe you might have deployed AKS type of Kubernetes services that are running on the containers where the system itself is continuously changing the configurations. The parts are getting deployed all the time and evacuated depending on the availability of the nodes. So in those situations, the only way to identify and recover your specific workload components or the microservice or a service is by using infrastructure as code, right? The native infrastructure as code is very important, and it is single touch, which means a low code mechanism to get that. And finally, test often, right? Without testing the recovery scenarios yourself, there's no way that you can be confident in yourself that you could recover that environment completely if there is a failure that happens due to various reasons that I explained before. So for that, we have automated resiliency simulation based approach. So in essence, think about the worst case scenario where your resiliency has been impacted because of various reasons. Now you are in a point where you have to recover. The only option that was available was that, go with some kind of a backup and recovery. In that case, you will have to have your application environment created with pre-created network. All the infrastructure is already set up. Now you recover that failed virtual machine, right? One after another maybe, or you could just bunch them together and recover in a DR situation. In this situation, you will have to think about configuring the IP addresses based on what's running already in production. Which virtual machine starts first? Which one starts next? And what are the groups of those virtual machines that really bring up your databases and other platform components of the application, right? You will have to do all of that yourself, right? Yes, the tools will help in terms of bringing back the data, some of these tools do not even know your application virtual machine size, right? If those virtual machine sizes change, how do you really recover? How do you know what happened a week ago in your production environment? The virtual machine sizes continue to change. What Appranix does is it makes it simpler, right? Appranix completely allows you to recover the infrastructure of your application environment completely, totally automated with a single touch, low code mechanism. Underneath of it, Appranix uses the cloud native infrastructure as code. It knows the dependencies. So this is a night and day, right? It completely recovers the entire thing with a single touch. And this is what people say about Appranix, right? Some of the interesting things like your product is dope, right? Where have you guys been? This is Microsoft solution architect saying that, right? One of the CIOs saying, I can sleep better at night because of Appranix. So very interesting thought process, and the system is available for you to use not only for recovering from failures, but also for test and dev purposes, right? You can make a fully, similar looking or the same as the production environment, what we call as a production twin. It's basically a twin of your production environment for your test dev purposes. Or you can make that production twin for your chaos engineering experiments. Think about it. If you have to do some kind of a chaos engineering test, chaos engineering is all about knowingly introducing the faults into the system and seeing whether that system is able to withstand those failures, right? In order to introduce those failures, you should be confident to introduce the failures. If you're coming from traditional backgrounds, data center based approaches, even to create a storage volume, you'll have to file a change request. If you have that kind of a thing, how do you really conduct chaos engineering experiments in your production environment? So we suggest make a production twin copy from your production environment, completely associated, deployed in a different region, in a different VPC. So your production VPC continued to run, no problem. And then you introduce all the chaos engineering experiments in that environment to a point where, let's say, 90% of the experiments are complete. Now you're confident that your system will work, even if there are failures. Now you introduce those changes into your production environment, right? Until then, you can run with a complete copy of your production environment in some other region. So make use of the cloud, make use of that infinite infrastructure available for you, make use of the tools like Appranix to run those experiments. And then ransomware recovery. I don't have to even say how fast you can recover, right? For that, let's do a quick demo as well. Any questions? If you have questions, please type them on the side. We'll be happy to quickly answer before jumping on to the demo itself. Right. All right. You can type away, and I will revisit those questions and quickly answer while doing the demo. So let's do the demo. Let's assume that you have an Azure environment. It's not as simple as what I have. If you think about resource groups, it's a great kind of approach that Microsoft has taken, that create a resource group for everything and anything that you do, right? So one such resource group runs a simple application called OpenEMR. OpenEMR is emergency medical records application, EMR application, and this is my doing. So if you think about that particular resource group, that is running in the central region of Azure, and it has all kinds of infrastructure, right? You have the network security groups, the public addresses, the EIPs, the load balances, obviously the virtual machines and the virtual machine scale sets and so on. So all of that. If you look at some of the network configurations, right? If you go into one of the virtual machine connection between two virtual machines using the security groups, you have plenty of these configurations. And this is very key because this is your security, right? And these configurations might be changing depending on how you kind of fix the problem whenever you encounter a problem, or whenever you deploy those application components or updating the components. So if you go into every one of these virtual machines, are the scale sets that you might have created to scale your application. Look at the configurations that you will have to really keep track of, right? And you can pretty much operate this virtual machine scales appropriately depending on the scale that you want to set, including the size of the virtual machine. And guess what? You can go and change the size of the virtual machine with a click of a button, right? So if somebody changing that virtual machine size, some other mechanism has to be there to keep track of what is changing. Otherwise, you won't have an idea what really happened 10 minutes ago, a week ago, a month ago, right? Or when the system used to run before the ransomware attack happened. And this is why the recoveries are becoming so costly and time consuming after the ransomware attack. It's not about paying $11 million to the attackers. It's about recovery. It's about knowing your environment. It's about the capability for you to confidently recover from the failed environments after encryption have been released. What if you had a choice where you are able to recover in a different domain, different subscription, nothing to do with your production subscription, completely different, because the attack might have happened in your production subscription, and in a different subscription, you are able to recover the entire environment, right? When you think about this application, it's a very simple application. This application has a bunch of patients, and all the procedures and the information about the patients and the reports for the patients is mission critical from a hospital perspective or a clinic perspective, right? If this application fails or is taken over by some other hacker, how do you really get back all this information really, really fast, right? That is where we give you that capability. In that case, assuming that you obtained an account, it's very simple to go and create an account. And once you create an account, once you log in, you simply land in a place called Cloud Connection Space, right? So Cloud Connection is nothing but you simply connect your cloud for discovery purposes, right? So you go into Cloud Connections. The Cloud Connection is as simple as just looking at Azure. You simply register your tenant ID. I hope you know where the tenant IDs are located. You can search for the console tenant ID wise. So you simply search tenant, right? Tenant properties and tenant ID, and you get the ID, you connect, right? So once you connect, we automatically discover your infrastructure. So if you going into a test connection, for example, we discover all your virtual networks or virtual network configurations, scale set VMs, security groups. How do you really go back in time with respect to configurations of the security group? All your network interfaces, the scale set, and the scale set and the VMs within the scale set, right? All your resource groups, load balancer configurations, so the storage accounts, all of that. I have not deployed a SQL database for my OpenEMR. It runs on a bunch of virtual machines here. So it is basically in a simple compute, but you can deploy a PaaS service from Azure, database PaaS service. Load balancer is a PaaS service, by the way, right? And you can pretty much discover that in Appranix. So once you discover it, you simply represent your application environment using a cloud assembly. Cloud assembly is nothing but an assembly of your cloud resources. In this case, you can say roughly a resource group. So simply associate a resource group with a cloud assembly. In this particular case, we happen to call that cloud assembly as OpenEMR assembly. And the OpenEMR assembly has a bunch of infrastructure. You can see 8 different resource types that mimics pretty much the resource types that you have here. So if you go into the resource groups, OpenEMR resource group, you go in here, you have a bunch of these resource types, and those resource types are running on the central region, as I told you before. Now, once you discover, you simply put policies. If you look at the policies, I am using just a daily policy. If you look at some of the policies, we have other policies here. If you go in, You can have an hourly policy, daily policy, 30 minutes policy, weekly policy. Again, retention changes. You can have 48 copies hourly for 2 days. And then the daily takes over with daily copies. You can have a 30 minutes copy if you want to get back to your previous deployment, even if you had some kind of a bad deployment scenario, right? Weekly, monthly, and yearly copies, 5 yearly copies, all forever incremental, right? Once you have that, then it's a matter of creating that application time machine, application environment time machine. It looks innocent, it looks simple. That's the point of the entire exercise anyway, right? You don't have to complicate this because Appranix is doing all the work for you. So if you go in and let's say June 7th, all the information has been continuously captured. So even if your DevOps groups, developers and operations, SREs, cloud operations, the managed service providers, the third-party applications have changed any of these configurations. They're all captured as of 3 days ago, right? As of 10 minutes ago, based on your policies. When every policies work, the policies are activated. Appranix automatically captures all of that, automatically takes care of the dependencies for those resources as well. And to make sure that the second region, in this particular case from central to east US, is automatically captured with all the data infrastructure, your regular infrastructure, all the network infrastructure, your compute infrastructure, all of that are captured automatically and ready to go. In that case, assume that you have a failure. What you have to do is to click that button, recover. You can actually recover in the same region. I have one resource group to recover, so I can quickly recover that particular resource group, or I can go to other region. If you want to just go back in time, you can go back in time to the 7th, and I will recover on the 7th. In the other region, I say that it's a webinar test, let's call it a test recovery, right? Test recovery. And other region, I can recover specific resources or entire assembly. And I have configured that to copy to the East US from the center. So it automatically select the East when you have only one other configuration for the recovery region. You can have multiple recovery regions as well. Of course, you have to pay attention to your cost, cloud cost, because it's easy for Appranix to create the right infrastructure, replicate the data to another region, but it is very important you take care of, optimize the cloud capacity and cost as well for based on your requirement. Now, once you have it, you simply hit the recover button, right? You can also turn on a scheduled reset. That way, even after the recovery, maybe that you are recovering for DR test purposes or chaos engineering test purposes or test dev recovery, test dev purposes. So you can simply say, for my performance test, I will run this environment completely disassociated from the production environment in a different region. I've run it there, test my performance, and make sure that all my components are behaving as per the requirements, as per my SLA requirements, right? And then delete it after 4 hours. So you can certainly configure in different ways. You hit recover button, right? If you have some kind of a DevOps pipeline that's cooked up, you can automate through that mechanism as well. If you look at a traditional recovery, including Azure ASR, Azure backup type of recoveries, which one starts your subnet first, right? Which one starts your scale set VM? So if you look at the amount of code that has been written by Appranix here, you can very easily see, your life has been simplified tremendously, right? So if you think about the level of code that has been written with that single touch, is that Appranix has taken care of a lot of those situations automatically because it knows what's changing in the production environment. It knows your target recovery region capacity. It knows the target region's availability of the resources, right? It knows the dependencies between your cloud resources that are deployed in your production environment. Even if you changed 30 minutes ago, if you changed a day ago, if you changed a week ago, all of that are recorded. We do not take your production application data. Your data stays as is within Azure. Appranix makes sure that the data is appropriately protected in the same region with multiple copies, using all the infrastructure, all the Azure native capabilities are available. So internally, we leverage all the Azure backup API, all the replication API, all the storage API that are available appropriately. Some of them are not even published yet, right? So we make use of all those capabilities that are already built in, and we manage that data infrastructure resiliency for you. Right? What Appranix takes is those configuration data over an encryption channel, 256 encrypted channel, and at rest 256 encrypted at rest per tenant as well. So that way it's all secure, and we have been certified. That's why it's available as a tenant registered SaaS application within Azure Marketplace, right? So all of that. Now, if you think about it, your configurations might be different on so many different levels. The reason why Appranix writes this complex Azure resource manager based code is because even if you gave 50,000 lines of code, right, it's Azure's responsibility to run it. If you have like a Terraform or some other third-party type of mechanism, you are responsible to throw in as many resources as required for your Terraform infrastructure, assuming that you have properly represented that infrastructure in the case of recovery for your application environment, right? So if you have Terraform, continue to run it, continue to use that for production reasons, absolutely no problem. In fact, we give you that stateful change as well. But for reliable, guaranteed recovery, it's important that you leverage Azure built-in capabilities, right? Load balancer rules, all the load balancer rules are available on the East Coast now, as of June 7th, right? So if you look at it, Appranix has created all those resources, all those dependencies automatically, right? For your test recovery OpenEMR. So if you go in, if you look at OpenEMR environment resource groups now, you have two, let's go back and come back from the resource group perspective. You have OpenEMR, OpenEMR that's available for the test recovery OpenEMR as well. So if you go into the resource group, the East Coast has now been populated with all the configurations. If you go into that security group, all the security group configurations are intact, including your tags are intact, right? So that when you deploy some kind of a management solution in your production, those all depend on the tags, they will all be intact. The load balancer configurations, your IP configurations are all available. So the production one, I didn't bring it down. It's running on 13.86, whatever the IP address is. Now, if you look at the virtual machine scale set here, and if you go into the recovered IP for the East Coast is different, and that application should be able to come up on the East Coast. So again, two different environments now completely isolated with each other, and the application is running on the East Coast, right? So this is 20.85, and the production one is 13.86, right? So those two application environments are now running with that single touch of a button, right? So if you go into the OpenEMR in the production, you have all the configurations, all the network security group for OpenEMR app 010 NSG. You can see all the configurations here. So if you go to the other resource group, test recover environment, and if you go into that same resource security group, you have all the configurations are intact as well. So that's a level of capability that Appranix gives you, and you have all the logs. You can go and take a look at deeper logs are directly available based on the deployment from Azure as well. So you have, again, a cloud native way to extract it. give you the higher level one, plus the insights. So you can go back and look at your production report. What kind of protection was offered for your assemblies, depending on the assembly, depending on the production, depending on the policy that you have configured. Every minute that capture as well, or recovery. So we go into the recoveries. We just yesterday, I think there was a recovery, and I did that recovery early morning, and then now it is kind of resetting automatically as well, right? So recoveries are available June 9th. I don't think I have a recovery here. You can go back in time, right? You can go back in time in terms of figuring out what kind of recoveries happen, and depending on the recovery type. So several reports that can be extracted depending on the situation. You can go back in time and get the reports, and recoveries are that simple. So if you take a look at how fast the recovery really happened, if you go to the timeline and recovery completed as of 2 minutes ago. So 2 minutes and 16 seconds to recover the entire environment, writing the code and recovering all other resources, right? Now you can go back and say reset it. So simply say reset and delete those recoveries, recovered resources, and you simply delete. In this particular case, none of the data will be deleted, because that is working as per the policy that you protect the data infrastructure appropriately for your application. What's getting deleted is all these additional infrastructure components, so all the scale set, the subnets and VNets and security groups, all of that will be automatically deleted so that you can reduce the cost as well, right? All the gateways will be recovered and reset automatically, right? And once you're comfortable, you can turn on the resiliency recovery simulation policies as well. So you can create a recovery simulation policy where you can instruct Appranix to go and recover automatically every month based on a particular policy. It will try the first policy, that's a first successful timeline. If it fails, it will try the next one, and so on. So you can keep on trying to make sure that the environment can be recovered, and more importantly, you can sleep better at night. Right? So with that, let me stop here and see if there are questions. I think there is a question here. Satysh, yes. Let's see what kind of. I have a question. So absolutely, I have a question. I might have missed. Does Appranix do a replication of between zones? Yes, we do automatically, because the replication is using the Azure replication, or we do rely on Azure built-in replication capabilities, right? And what we do is that we automatically, based on the policies, we control that replication using built-in Azure incremental forever type of replications. So when Azure continues to release those changes, more and more capabilities, more and more zone and region supports, we can automatically take advantage of that. For the application consistent backups, we leverage the backup API that is available. Again, all the built-in. In this case, what happens is that the savings-wise, Appranix is automatically paid for. So you can remove Azure backup as a tool set, so you don't have to pay per VM, and then 500 gig incremental as almost like 1 VM coverage. You can remove all of that. You can remove ASR. Pretty much you have built that capability from the ground up as a SaaS solution. It directly works using the API that are available. So all of that native capabilities you take advantage of. You don't have to put additional data infrastructure. That is one of our clear value props. Now, if you try to put another data management solution, another backup solution, what happens is that now you're pulling the data from all those virtual machines, particularly when you auto scale, backup engines won't even kind of catch up to the auto scaled infrastructure, right? Those were all created for a data center when auto scaling was impossible. So how do you really put an agent and expect that to catch up with your backup manager, right? So that's why you have to do forever incremental all the time, no agents, right? And leverage cloud built-in capabilities. That way you don't have to go through the network, production network at the front, right? So that's very, very key. So yes, we take care of that automatically. Any other questions? All right. Again, thank you for your attendance. I really appreciate it. The webinar will be available as recorded one on YouTube on our channel. We will send you the recorded webinar after probably tomorrow once I kind of edit a little bit and then upload it on the YouTube. So that's available. So if you have your colleagues that couldn't attend this webinar, please send it to them so that they can take a look at it as well. Okay. So with that, I give you back about 4 minutes. So really appreciate you joining and have a great day. Thank you very much.